Hi guys, so this is an example video, which means that I assume that you kind of already know the basics of logarithmic differentiation. If you're looking for an overview of how it works, highly recommend you check out the lesson version of this video. In this example video, I'm going to go through 4 examples. These are the 4 examples that I'm going to go through. So this can be a really great opportunity for you to quiz yourself. Pause the video here, try these, and then hit play when you want to see the solutions, or you can just scrub the video and find the solution that you are looking for. So starting with this first one, so I'm going to use logarithmic differentiation for all of these. So to do that, what I have to do is I have to take the natural log of each side, and then I need to expand the right side as far as possible. So that's going to be nice and straightforward in this case. So basically all of these different factors, I'm just going to break them up by addition. So what I'm going to do is write this out as the natural log of x, and then the natural log of x minus 4, and then the natural log of x plus 5, and then the natural log of x plus 2 to the 7th. And then for this 7, I can bring this 7 down in front, so rather than writing out this whole thing, I'm just going to rewrite this. It says 7 times the natural log of x plus 2. Okay, so that's as far as I can possibly expand that. And now I'm going to take the derivative. So this is going to be 1 over y dy dx. So I'm using implicit differentiation. And then this first one, this is 1 over x. So using the chain rule here, this will come out to just 1 over x minus 4. And then when you take the derivative of the inside function, it just comes out to 1. So I'm really just leaving this as 1 over x minus 4. And all of these derivatives actually work out really nicely, right? So this becomes 1 over x plus 5, and then this becomes 7 over x plus 2. So it's a nice straightforward derivative. And then to finish this off, so now I just need to bring the y over to the other side. So this will be dy dx, and then y, and this stuff, just like this. And then usually what you want to do is you want to replace y with the original problem. So if I clear a little space, now I can restate this one last time as dy dx equals, and then I've got x times x minus 4 times x plus 5 times x plus 2 to the 7th. All of that times 1 over x plus 1 over x minus 4 plus 1 over x plus 5 plus 7 over x plus 2. And you could probably keep simplifying with that if you wanted to, but we'll call that good. So this next one is another example of using logarithmic differentiation, and maybe just something to point out here. So with this last one, so you didn't have to use logarithmic differentiation for this, but it was nice because you didn't want to have to actually multiply all this together, especially this part here, this x plus 2 to the 7th. Obviously you wouldn't multiply that out, you'd probably want to use the chain rule. Or you could have used the product rule on all this, but that's just a lot to keep track of. So the nice thing with logarithmic differentiation is it just gives you another path, like another way to kind of evaluate some of these trickier derivatives. So this is another case where logarithmic differentiation would be good because there's just a lot going on in this problem. And so if you like working with logarithms, then this can just make your life a little bit easier. Okay, so first things first, if you don't have this in terms of y, that's going to be what you want to do. And then you want to take the logarithm of each side. So we've got the natural log of y equals the natural log of sine of x over x squared plus 5 squared, and then all of this to the 1/3. So I've got this, and now I'm going to use my properties of logarithms to break this up. So first things first, I need to bring the 1/3 out in front. So this is going to be the natural log of y equals 1/3 times the natural log of sine of x over x squared plus 5 squared. And now I'm going to break, this up with subtractions. Let me clear some space. So Just don't forget about the 1/3 in front here. So I'm actually going to draw some square brackets so that I don't forget it. So this is 1/3, and then this is the natural log of sine of x minus the natural log of x squared plus 5 squared. And now you can see that I can bring the 2 out in front. So actually, instead of me rewriting the whole line, let me just redo just this part here, okay? So I'm going to rewrite this so that the 2 goes here, and then I've got the natural log of x squared plus 5. Okay, so now I can distribute the 1/3 if I want to, or you could just multiply the 3 over to this side. So this becomes 3 times the natural log of y, and then you've got the rest of this stuff, which can be nice because then you just get rid of the fraction. I'm always a fan of getting rid of the fraction. Okay, so now let's go ahead and take the derivative. So I'll need some space. And so this side's going to be 3 over y dy dx, and then this side is going to be, let's see, that should have been 1 over sine x, and then I multiply this by the derivative of sine because I'm using the chain rule here. So the derivative of sine is cosine of x minus 2 over x squared plus 5 times 2x. So now if I clean this up, so cosine over sine is cotangent. So let's write this as cotangent. And then this will be minus 4x over x squared plus 5. And so now we know that I need to multiply this y over, but instead of writing this as y, I'm just going to write this as the original function. So let me clear some space. And so ultimately I'm going to have dy dx equals, so I brought this 3 over to as 1/3. Then I multiplied this by y, but I'm going to replace it with this function here. So this is going to be the cube root of sine of x over x squared plus 5 squared. And then all of that times the cotangent of x minus 4x over x squared plus 5. Whew. All right. So again, is this actually easier? I mean, it kind of depends, right? So this would have been a pretty gnarly chain rule. At least this was like pretty straightforward in terms of taking the derivative. It's a lot of stuff to write down, but I think the derivatives themselves are easier to take than this. But part of that is just coming with experience and practice, so you'll make up your own mind about it. Okay, so this next one, so notice this one is not in terms of y, it's not nicely written, but if you wanted to implicitly differentiate this, so you actually can't just start taking derivatives because we don't have derivative rules for this. So this is something I talked about in my lesson video actually. So the only way you can take this derivative is by taking the natural log of each side. So if I take the natural log of each side, then I can bring down the exponents. So this becomes y times the natural log of x, and then this becomes x times the natural log of y. And now you can take the derivative of each side. So I have to use the product rule on each side. Highly recommend you pause the video and actually try to take this on your own and then watch. So in taking the derivative here, so first I take the derivative of y, so this will be dy dx times the natural log of x plus y times 1 over x. And then this side is going to be 1 times the natural log of y plus x times 1 over y. And I forgot my dy dx. So now I got to get my dy dx together. So I'm going to bring these two terms together. So let me maybe underline that. So this and this need to be on the same side, and then this and this need to be on the other side. So let's just go ahead and jump to that step. So I've got dy dx, and I'll factor that out. So this becomes the natural log of x minus x over y. And then on the other side, this is the natural log of y minus y over x. Okay, so let me make some space. And now the final answer will be dy dx, and then this is the natural log of y minus y over x, and then the natural log of x minus x over y. And so in this case, right, it's not like you can isolate the y or anything, so this is just going to be in terms of x's and y's, and so that's fine. And so this last example, this is very much the same idea. So with this one, we don't have a way to take the derivative of x to the x or anything like this. So we're going to have to use logarithmic differentiation. So I'll go ahead and I'll just take the natural log of each side, and then I can bring that sign of x down, which will then allow me to use the product rule. Oops, and this should be natural log of x. Okay, so this will be 1 over y dy dx, and then this is cosine of x times the natural log of x plus sine of x times 1 over x. Now, in this case, this would be easy enough to get the y by itself. So as I continue to solve this, I've got 1 over y dy dx equals cosine x times the natural log of x plus sine of x over x. And from here, you know I have to multiply by y to get dy dx by itself. And when I do that, so this is a case then where y is really clearly stated, so then I would actually rewrite y like this. So making some space, and this will be dy dx equals x to the sine of x, cosine x times the natural log of x plus sine of x over x, and boom, done. And so that'll wrap it up for this video. So hopefully that was helpful, guys. If you got any questions, you can leave me a comment. I'll talk to you guys next time.